Okay, today we will learn some more life cycle model of software development life cycle model, more characteristic of SDLC. The first one is incremental and iterative development model. The key characteristic behind this model is to build the system incrementally, consists of a planned number of iterations. Each iteration produces a working program, and the benefit is facilities and manage changes. So you have to build your system day by day incrementally. At the first time the core of the system will be developed, then some more functionalities will be added, then some more functionality will be added, and like a way the whole software system will be developed. And each and every development process is called an iteration, and it's going like a single waterfall model or classical waterfall model. Like this, at the first increment, the phases of waterfall model: design, build, install, and the customer feedback will be taken into this first increment. On basis of customer feedback, it will be changes. If the changes are necessary, then it will go into the next increment. And in the next increment, again we will develop some more functionalities on that core software, and that design, build, install, customer feedback will also be used in that case also. So up to this type of increment has to be developed. Through this type of increment your software will be developed. The waterfall model is a single release model. There is no incremental model, there is no incremental approach and no iterative approach. In the iterative waterfall model, it is actually many releases, and the first increment at the core functionality is to be developed. The successive increments you may add fix or functionalities. Final increment, the complete product will be developed. Each iteration of a short or many project with a separate life cycle are actually each iteration is faces the each phases of the waterfall model, classical waterfall model. So there are many classical waterfall model in a single iterative waterfall model. Okay. Evolutionary and iterative development process actually recognize the reality of changes requirements. In real, the Cap Jones researches on 8,000 projects, and he found that 40% of the final requirements arrived after development had already begun. So these 40% of final requirements has to be incorporated in your project, and if these requirements come after completing the whole project, then to accumulate this type of requirements into your project are very much tough work. So you have to take an iterative process, when for each and after each and every iteration, if the new requirement comes up, you can easily accommodate it into your software. It promotes early risk mitigation. If as you break down the system into some mini projects and focuses on the riskier issues first, so each and every iteration you are focusing on the risk. So each and every time your software has been checked that it is risky or not. So each and every little module plans a little, design a little, and code a little. So you have not think a large thing at a time. So it will be very fast task and easy task, and obviously the better software will be developed in that way. It encourages all development participants to be involved earlier on. The end user, tester, integration, and technical writers will not be wait until unless the software has been prepared. So the end user can work after the first iteration. They can use the software, they can give the feedback. After the first iteration, the tester can test the core module, then the next iteration, the next developed module, and then the integration process, and the technical writers can start the user manual after the first, second, third iteration effectively. So this is the core development evolution of the software development process. At the first time, the core of the software, that is A, has been developed. Then the new functionalities like B will be incremented on that developed software, and the tester will test the B as well as A, not only B. And the next, the C functionalities will be developed on that A and B model, and when the tester will test the C module, the A and B module will parallel test it again. The evolutionary model first develops the core modules of the software, then the initial skeletal software is refined into increasing levels of the capabilities, that is the iterations. By adding new functionalities in successive versions, the iteration will go on and the software developed over several mini waterfall models. Each and every iteration of the software is a single waterfall model. The result of a single iteration ends with delivery of some tangible code, and incremental improvement of the software leads to evolutionary development. So if the process is incremental approach, then the evolutionary development has been established. So and with this delivery with some tangible code, each and every iteration, that code has to be tested, that code has to be installed, and that to be tested again, give the feedback through the user. The outcome of each and every iteration is tested, integrated, and executable system. The iteration length is short. Normally the iteration length is between 2 and 6 weeks, but that each and every development are consist many iterations, for example 10 to 15 iterations. It does not freeze the requirements and then conversely conservatively design. Opportunity exists to modify requirements as well as design. So at the first time the requirement never freezes. The user may, the customer may edit the requirements in the time of development phase, and normally though we have found that normally the history says this, that when the development process starts, the 40% requirement comes out, and that's why that's why when the requirement comes in the development space stage, at that time the software, it is easily to modify into your software. The successive versions, the functioning system capable of performing some useful work. A new release may include new functionality. Also existing functionality in the current release might have been enhanced. The user get a chance to experiment with a partially developed system much before the full working version is released, helps finding exact user requirements, the software more likely to meet exact user requirements. The core modules get tested thoroughly. It reduces the chance the errors in final delivered software. The better management of complexity by developing one requirement at a time, better management of changing requirements. It can get customer feedback and incorporate them much more effectively as compared when customer feedbacks come only after the development work is complete. The training can start on an earlier release. The customer feedback taken into account. The frequent releases allow developers to fix unanticipated problems quicker. The process is intangible, no regular well-defined deliverables. The process is unpredictable, that is hard to manage, that is scheduling, workforce allocation, etc. The systems are rather poorly structured. These are the problems of evolutionary model. No regular well-defined deliverable project has been developed. It is hard to manage, that means scheduling is not possible. The work allocation is not possible. When the new iteration will start, at that time the scheduling and work allocation can process for each and every iteration. The continual unpredictable changes tends to decrease the software structure. If the unpredictable changes happen in each and every iteration of the software, then it decreases the quality of the software structure. The system may not even converge to final version. An unpredictable change and a heavy load of changes may makes the system fail. We will finish into this. The next, from the next day we will start the spiral model.